Ji, Assalamu alaikum. We're just going to start with the last lecture, and I'm just want to give you one example where I will discuss the curvature and try to find the relationship of this curvature with the radius of a circle, how the relationship there. So we're having a circle, and circle is a fixed one, its radius is fixed, and we can have the equations. We have defined already before that we can write in a parametric form. Obviously, it will be 2 dimensions. Also, we can write the equation as vector value function r of t. So we can have here, this is my x is equal to a sine t. And here we write in the form of the parametric y equal to a cosine t. And when I want to write the vector value function, then we can have r of t is equal to a sine t I plus a cosine t j. So we know that when we take x square plus y square, that is equal to a square is the equation of circle. We have a square sine square t plus a square cosine square t. When we take a square common, that means sine square t plus cosine square t is equal to 1. And then we can say that our x square plus y square is equal to a square equation of circle. We can just verify that one. But here we have the equation r of t is equal to a sine t I plus a cosine t j. Now to find the curvature, we need here the tangent to the curve, that's the unit tangent vector. Unit tangent vector we can find by the motion for the velocity. Velocity is r dash of t. We take magnitude of the velocity. And then we divide by the magnitude, we get the magnitude of the vector, that's velocity vector, we get the unit tangent vector. So we can just see our formula for curvature, that's equal to t dash of t, that is unit tangent vector, derivative of that one, and divide by r dash of t, and that's our velocity vector. We can just say this r dash of t. Now to find t, we find r dash of our given equation r dash of t, the derivative of this function, that we can say this our r dash of t is equal to derivative of sine t is cosine t. We have a cosine t I, then derivative of cosine t is minus sine t, that's a sine t j. I take the magnitude of this one, r dash of t, magnitude of this. Again, we have here a square cosine square t plus a square sine square t under the root. So here we can take a square common, and we take a square common from the root, we get here a out, and we get here cosine square t plus sine square t. And you know this trigonometric identity, that cosine square t sine square t is equal to 1. So this give me this value of a dash of t magnitude is equal to a. Now I want to find here t. What's my t? Unit tangent vector. My unit tangent vector is equal to r dash of t divided by magnitude of r dash of t. This is just definition of any unit vector, which is vector divided by its magnitude. A vector is r dash of t or divided by magnitude. So when I divide this by magnitude, I can have here 1 upon a. This is 1 upon r dash of t. And the vector is a cosine t I minus a sine t j. Now I divide this by a, I will get here my t of t. Unit tangent vector is equal to cosine t I minus sine t j. Now I will find here t dash of t. Derivative of this one, this is equal to minus sine t I. Derivative sine t is cosine t. So I have cosine t j. Now what is our formula? Our formula for curvature is that we divide this one here t dash of t by magnitude of r dash of t. So we use this formula, and we can write our curvature k is equal to t dash of t, magnitude of this one, divided by r dash of t. So I find here the magnitude of t dash of t. Magnitude of t dash of t is simple here, we can find immediately. That's equal to sine square t plus cosine square t. Root of this is equal to 1. So I can write this equal to this 1, and what's r dash of t is a. So my kappa is equal to 1 upon a. So this is my curvature of circle. Curvature of circle of radius a. So you can see here that if I'm going to increase my circle radius, a is increasing, then my kappa is decreasing. And when my a is decreasing, then my kappa is increasing. So as I mentioned here in the last example, that for example, I have this curve like this one. But here, if I take the circle, this of this size. If I take circle here, then the size of a circle is increasing. This is my circle. This must be tangent to the curve here. At this one, this tangent to the curve. For example, I take it here. Now this my circle is here. Now for this one, we can define the radius of curvature. This is my radius. This is my radius. This is my radius. You can see it here. This radius is here. The curvature is smaller. Here the curvature is bigger. When radius is bigger, the curvature is smaller. This is reciprocal of this one. So here the same thing. So when radius is increasing, then curvature is decreasing. And we have, when the radius is increasing, curvature. For example, we said that the equation of the straight line, and we find the curvature. Curvature of that one is equal to 0. And when we have this angle here, like this one, here we say the curvature is minimum. And here we have the curvature, oh, big one, like this. So that's the curvature is changing from point to point. And curvature, moreover, say we have the unit, this tangent vector to this one. This is the rate at which the unit tangent vector is changing. That's why we take dv by dt in principle the curvature. That gives us from the definition. When we take the definition of the velocity and differentiate that one, we can derive the formula from there. So the idea was that we're having the curvature, and curvature is reciprocal of the radius. When radius increases, curvature is decreasing. And when radius is decreasing, curvature is increasing. So we are going to discuss the radius of curvature. Now radius of curvature is along the curve, and at the point P, when we say we want to find the radius of curvature, at the point P, the tangent to the curve is the same tangent to the circle. So they are common. So at that point we can have discussed before as the curvature, and I try to find the relationship for our circle, the radius of curvature and the curvature. So we have seen our curvature is 1 upon the radius of it. So radius of curvature is 1 upon kappa. So we can just write that immediately. So the second is to find the center of curvature, the point for that. With circle, we have the center, we have the radius. There are different way for finding the circle of center of curvature. I'm just taking the formula for that one. Assuming x minus the point xy, we want to find the circle of center of the circle of curvature. And for each point, the center and the radius of curvature is changing. As I've given you the example above, at each point there will be change in the value of the curvature, and also the value of the radius of curvature, and also the center of curvature. If the curvature is increasing, then obviously we say the radius is decreasing. Then obviously the center is also changing. So here we are having this formula, that is point xy. We are having this h, the x value of the center of curvature, ky is the k value of center of curvature, where x is equal to x minus y dash plus 1 plus y dash whole square, and divided by y double dash. And our k, the y component, is y plus 1 plus y dash square. Alright, I give you the example for this one, I explain you with the help of example. I give you the example for finding the curvature of the curvature and center of curvature and radius of curvature of the function. I have the function y is equal to 2 minus x cube, and at the point 1, 1. Sometimes we given the point x equal to 1. Then we can find the value of y also, putting the value of x equal to 1. We have done last time different formulas for finding the curvatures. We find the curvature for the function y equal to f of x. We find the curvature of the function r of t, vector value function, is f of ti plus g of tj. And in 3 dimensions, we have find the formula for curvature of the function when r of t is f of ti, g of tj, and h of tk. Because we have the function y equal to minus x cube, this means y is the function of fx. So when I have y equal to function of f of x, then we have the that is y is equal to f of x. We can write the formula for the curvature. Formula for the curvature is y double dash. Curvature is always positive, so we take the absolute value, and then we having here the value of 1 plus y dash square to power 3 by 2. So obviously we can find the value of y dash and y double dash at the point given, and we can just substitute the formula, we find the curvature. My y is equal to 2 minus x cube, and I can find my y dash. My y dash is equal to this is here minus 3x square. I find y double dash. My y double dash is equal to minus 6x. Now at point x equal to 1, 1, y equal to 1, x equal to 1, at the point, I take here point, because our right values are only calculated 1. So we say y dash is equal to minus 3, and y double dash is equal to minus 6. So I substitute the formula, my kappa, the curvature is equal to 1 plus y double dash over 1 plus y dash square to power 3 by 2. We applied this formula last time. I gave an example to you also. So we have the curvature is y double dash, absolute value 1 plus y dash square 3 by 2. Now y double dash is minus 6. So get here minus 6, we take here minus 6, absolute value of that one, over 1 plus 3 whole square, 3 whole square is 9, to power 3 by 2, and we are having here the value of absolute value of minus 6 is 6, as I told you, we are having always this as positive, to 10 to power 3 by 2. So it's my curvature. Now we have seen our radius of curvature. We are having the radius of curvature is 1 upon kappa, that's reciprocal of that one. So we take reciprocal of the value of the curvature, that gives me radius of curvature. So that gives me 10 to power 3 by 2 over 6. That's my value of the radius of curvature. Number 3, we want to find the center of curvature. So to find center of curvature, we having all the values. We have to substitute only curvature, which I write on the formulas for that one. Want to find h and k. To find the value of h, we are having here the value of x, that's over 1 minus y dash into plus y 1 plus y dash square over y double dash. So we just have the values of y dash and y double dash. We substitute these values, and also we have the point given to us is 1 1, that's x equal to 1. We just substitute the value in the formula and we can get the value of x value of the center of curvature. So this my x is equal to 1. I am here x equal to 1 minus y dash is minus 3, and 1 plus y dash square is 9 over minus 6. So minus is cancelled with minus and get here 1 minus 10 over 2. So get here 1 minus 5 is equal to minus 4. This is my x value. So to find my y value, we are having here the value of k is equal to y plus 1 plus y dash square over y double dash. So we are having y again, the value of x is 1, y is also 1, plus 1 plus y dash square is 1 plus 9, y double dash is minus 6. So that's just give me this equal to 1 minus 10 upon 6, and this here is 1 minus 5 upon 3. I simplify this one, we get here 2 upon 3. So I can say here my center of curvature, just I am making the calculations, this is equal to the minus sign. So my center of curvature is equal to, my h value is minus 4 and my k value is minus 2 by 3. So this is my center of curvature. So that's how we can find our radius of curvature and center of curvature for any given function. You have to find y dash, you have to find y double dash. You have the formulas where you substitute that one. You can find this. And this important thing is changing for each x and y. So when the point is changing, the value of h is changing, the value of k is changing. And even if this rho is changing, also these values are changing. So you see along the curve, the motion we are going to describe, and we are describing the curvature of the curve. So curvature of curve is different at each point. So because our x, y is changing.